Hey everybody, it's Mrs. C and I am coming to you today with a video on solving inequalities. I was looking back, I was telling people, well, go look at the video on YouTube that I did on inequalities, and then I realized, oh my gosh, I didn't do any videos on inequalities. How, I ask you, could that happen? Well, I had all my videos on another site and won't go into all that, but all those videos that I did when I first started out, you can't access them. So I'm going to do another video on inequalities, and for my YouTube fans, of course, it'll be the first. So let's just jump right in. Now, inequalities are extremely similar to equalities or equations in that they express a certain circumstance. So let me just write one down here. Let me see. How about we say 3 is greater than a negative 5x plus, say, 2x. And let's just ask ourselves, how is this different than 3 equals a negative 5x plus 2x? Well, it differs in one major way. Let's just take a look at what 3 equals a negative 5x plus 2x actually gives us in terms of what is x equal to. Well, if I combine my sides first, like we always do, as all good algebra students do, right? We get a negative 3x, and that's equal to a 3. Divide both sides by a negative, and I wind up with x being equal to a negative 1. Okay? And so that's the basics of an equation. You wouldn't have made it this far, right, if you didn't already know that. Now, how do we check that step? Clearly, we just have a little process we call an evaluation step, and we evaluate for wherever x is. We would plug in a negative 1. Some of us use our computer or calculator to do that for us using a store function, or some of us just can do it old school. I don't have a calculator on me right now, so I'm just going to do it this way. And I evaluate to see if negative 1 actually makes this side true. So a negative 5, I'm over here, a negative 5 times a negative 1 is actually a positive 5. I'll just write that right on top. And over here, right over here, 2 times a negative 1 is a negative 2. And if I put those two together through addition, I would have a 5 minus 2, or a positive 5 combined with a negative 2, which would give me, wow, it's a lot of blue, isn't it, a 3. Well, over on this side, I had a 3, and over on this side, I have a 3. And in between them, I have a equals. So basically what I just proved was that 3 is equal to 3, given the value of x as negative 1, excuse me. So the cool thing is the only time that this equation up here, that we, with all the blue, is ever going to be true is if, and meaning ever going to be true, where both sides are equal to each other, is if x is given the value of a negative 1. Okay, way too much colors, like a rainbow threw up on my paper. So let me just erase all of that. All right, now let's take a look at what happens when you deal with this as an inequality. But noticing that I did a little division step, I'm just going to bear with me for a minute. I'm going to change one thing just for my introductory, and you just fix it with me. Let's do that same equation as an inequality, but I'm going to change my 2 to the negative and let my 5 be the positive. And in a minute, you'll see why. So let's, for example, find out how an inequality, aside from the little sign shift I did, would be different and the same to an equation. Well, here's the good news. You solve it the same way. You combine the right side. This case, since I changed the signs, I have a positive 3. That's all. I was just trying to keep everything positive. We want positive feelings, people. All right, so I combine a 5x and a negative 2x, and I get a 3x. I have a 3, and instead of an equation symbol, it's just the inequality symbol that's coming down. The last step on the one before, I divided both sides by 3. I still divide both sides by 3. I still get an x on the right. I still get a 1. In this case, I'm getting a 1 because remember, I changed the sign. And then I have an inequality symbol. And this is actually my answer, guys. I know that 1 is greater than, or 1 is bigger than x. Well, what does that tell me? Number one, it tells me I don't just have one answer. I have a whole bunch of possibilities. So let's look at that on a number line. And we always graph on a number line when we do solutions to inequalities because the solution covers a range of numbers, not just one number. So for example, on the last problem where x, if you remember, was equal to -1, I would plot, or I would represent that graphically. I always put 0 in the middle, and the -1 is to the left, right? If I was going to actually represent x is equal to -1, I just put a point. That's it. There you go. The point represents the solution, and x is equal to -1, and so I put a point on -1. But this over here is not a point. It's an inequality stating that not just one answer is a solution, but many or infinite answers. So how do you graph an inequality? Oh, it's so easy, I'm telling you. It's the easiest thing we ever do. So first of all, let me just excuse me, pardon me. Just a quick little cleanup here. First of all, I digress, and I don't want that stuff in the middle of what we're doing. All right, so the first thing, when you have an inequality, and currently we have the inequality of 1 is greater than x, we want to draw a number line. And guys out there, I put 0 in the middle because 0 is the point of all origin. And then whatever number I have in my solution, I plot it to either the left or right of 0. Now, +1 is to the right of 0, and that's it. I put a 1 on the right of 0, done. Now, not done, because I didn't show who's the solution. Well, it says over here that 1, you see it, is bigger than x, and x is the value that I graph. And so a lot of people don't like it written like this. They prefer to put x here and 1 here. Because, I don't know, when we do our answers, usually we start with x, right? X equals, or x is not equal to. And so in this case, if you do want to switch them, you want to make sure that this inequality sign switches as well. Meaning you still have to be opening, if you notice, to the 1. So how would I do that? Like that. I'm still opening over here, down at the bottom in the blue, to the 1. 1 is still the bigger number because my inequality is opening towards it. But now I read it a little bit different. Same thing, but different. Instead of saying 1 is greater than x, with my blue, which is what I want to graph, I'm saying x is less than 1. Well, of course it is. If 1 is bigger, then x is smaller. That's all. It's just potato is what we say. So, first and foremost, if it's a greater than or equal, meaning it's an open interval, like this, we open circle around the 1, like this. Now, this is not the first time many of you have seen this. Open circle on open intervals. Had these had lines underneath them, then they would have been less than or equal to, greater than or equal to, they would be solid instead. 1 means to include, that's these. The other means to exclude, meaning I don't count the number I'm on, and that's why we put an open circle. So, talk to me. What the heck am I supposed to do? Let's clear. If my solution is x is less than 1, we drew the number line. You know what to do. 0 was in the middle. 1 was here. I said if it's an open, which it is, you put a circle. And now which direction to use shade? Lots of people have tricks for shade. I don't do tricks. I just think to myself, what's happening? Who is x? That's what I'm shading. Who is x? It says right here that x is all numbers that are less than 1. That's what that symbol means, the less than symbol. X is less than 1. In which direction, guys, are all numbers less than my circled number? You got it. To the left. Those are my negatives. We call them negative infinity. And in this direction are my positive, or my positive infinities. Infinity just meaning the arrow goes on forever. So if x is actually a value less than 1, shade in the direction of all numbers that are less than 1. Easy breezy, lemon squeezy. Let's try another one. Okay, so here we go. Let's try this one. Now, again, let's go over how similar they are to regular equations. Nice little line down the center. It doesn't really look like the center. That's why we put the line there. Combine terms first. That would give me negative 2x, and then a positive 2 and a negative 3, minus 1. Bring down that little inequality. Bring down the 9. Now let's move our numbers over to the left since I already have all my letters on the right. I'm going to add 1 and add 1. Now I have a negative 2x and that symbol and 10. Okay, I'm going to continue, and here is where you're going to see why I changed the problem before to a positive. I'm about to get x by itself by dividing by a negative. And here's the other major, pretty much the only major difference besides when we get our answer, we have infinite possibilities that we graph. And here's probably the last difference. When you divide or multiply by a negative for an inequality problem, you have to flip or make the sign change, the sign in the middle, the inequality sign. So watch this. I am dividing by a negative. No longer will I have the original greater than or equal to sign. I will switch directions, turning it into a less than or equal to sign. When do you do that? Whenever you divide by a negative, or possibly if I had multiplied by a negative. Some of you might be saying, I don't understand when you would multiply by a number. I'll do the next problem like that. So in this case, I'm going to divide both sides by a negative to get my x by itself. What's with the x's always being on the right? And then 10 divided by a negative 2, same old thing, guys, no different. It's a negative 5. There's my answer. You may want to express it in the opposite way. I do. I like my x's on the left. But notice, my inequality symbol is opening to the x, so let's make sure it's still opening to the x. When I do that flip, I do have to change those signs. Okay, symbols. I shouldn't call them a sign because it makes you think I'm talking about the negative and the positive. Okay, my answer is x is greater than or equal to negative 5. Now I have a little cheat sheet on the next page. Let's take a look. Was that true? Was that true? Yes, it was. You don't have to look at that. You can always pause if you want practice. But right now, I'm only using it as an answer key. Okay, what do I still have to do? I still have to graph it. So let's come over here and graph. I find graphing to be pretty much the easiest of the things that we do. Let me just change colors so that it's easy to see. Here we go, a graphing, a graphing, a graphing. All right. So 0 in the middle. Is my negative 5 to the left or right of 0? It's on the left. Do I have an open or closed interval? That's this. Oh, that's a close. It has the line underneath it. What does that mean? Solid circle. Now, x is greater than negative 5. Which direction are the numbers bigger than negative 5? It would be to the right. And that is the direction. Oh. Da-da-da-da-da-da-da. Isn't it nice? Da-da-da. Okay, enough. Well, that is my alarm to wake up. And guess what? I'm awake already. So I'm going to keep pushing through. All right, so we have the solution written. X is greater than or equal to a negative 5. And now we have the solution graphed. Here is what it looks like to be all numbers greater than or equal to negative 5. The fun thing about inequalities, and this is probably the most important thing for you to understand, is the relevance of the solution graph to the original problem. So let me take a moment to just clear out the excess. So I think the biggest problem is that when you solve an inequality, and it's usually right after equations, you don't really understand, well, why am I graphing now all of a sudden? And it's really important because graphing, guys, is a visual picture, so to speak, which aren't all pictures visual. It's a picture of what the answer is. And no longer is the answer just a point at -5. It's all the solution shaded. But what exactly does that mean? Let's take the value 1. Now, 1 is to the right of 0, not to the left of 0. And the answer I got was -5. Not 1, but 1 is in the shade. And if 1 is in the shade, then 1 is also a solution to, guess what? This inequality. And you might be thinking, how is that possible? How can I have more than one answer? Watch. If x really was 1 and not, I don't know, say -5, what would happen to this inequality? Well, you would wind up with a -2 here, right? Because a -2 times 1 plus 2 minus 3. Now, these two cancel out. A -2 and a +2, when you add them together, you get nothing. And what you're left with is a simple expression here. You have a 9 on the left, an inequality. I'm just copying what I have left. This is gone, and I have a -3. What does that say to you? It says 9 is greater than or equal to -3. And that is a true statement. 9 is actually greater than. It's not equal to, but that's why I say or. Greater than or equal to a -3. And that's true. And so what does that mean? It means the value of 1 would actually be a viable solution in this inequality. Now, what would not be a solution if you take a look at the picture we have drawn? If you look at our visual, what would be a number that you know automatically wouldn't work if I plugged it in? Well, anything over here. Give me a value of what you think that is. Some people might say, well, it looks like it's a -7. Okay. -7, -10, -20, -100, they're all infinitely to the left. And because they're outside of the shade, they should not make this equation true. They should actually do the opposite. They should make the equation a lie. So how do we test that out? Well, first we would actually want to swap in the value of a -7. A little kind of tricky since I went and wrote on top of everything. So you'd have to make this a -7. What do you get? -2 times -7, 14, right? I'll help you out. Plus 2 minus 3. Well, 14 plus 2, 15, 16, 16, and a -3 is what? 13. Got it. Okay, so this right side is not -3. It's positive 13. Now we have an expression that says 9 is greater than or equal to 13. Oh, no. 9 is not greater than or equal to 13. 9 is actually smaller than 13. That is a false statement. Just telling me what I already knew. -7 lies outside of the shade. -7 is not a solution to this inequality. So let's recap real quick. What did we figure out? We figured out that inequalities are really similar to equations, with a major difference in two things. How you express the solution, for example, x is equal to 5, or let's say x is greater than 5. X is equal to 5 would be graphed like this. That's x is equal to 5. X is greater than 5 would be graphed like that. Now, because it's an open interval, I'm not including 5. Where on this side I did include 5, and in fact 5 was the only thing. On this side, because it was not a closed interval, I actually excluded it. How would I include 5? I would just change that to a line that would actually include 5. So that is one of the major differences in inequalities and equations, is that with inequalities, you have an infinite grouping or set of solutions, and on an equation, there is one answer, and that is all. Now, what is the other major difference? It's in the process. If you have a, let's say, I got a good one, let me change the color. If you have 2x equals 10, and I wrote a 5, said 10, wrote 5, versus 2x, let's say, less than 10. And let's change one little thing. Let's make it a negative 2x. Here's the other major difference. Negative 2x equals 10. Divide both sides by a negative, right? Easy breezy. X is equal to negative 5. The one and only solution. And if I was to do the other one, I would go about the same process, but the minute I divided by a negative, what did I tell you needed to do? Switch the signs. So everything the same except for a sign switch. So in the case of x is greater than negative 5, how would that be graphed? Well, I would just have to get rid of this one because it's a totally different inequality. And I'll just leave the extra. I would draw my arrow. Ta-da! Well, don't we all know the snooze never lasts very long? Draw my arrow, 0 in the middle, negative 5 on the left, and here's the fun part. X is bigger than negative 5. Where are all my numbers going? Bigger to the right. So it's an open shading to the right, shading all values. X is the shade, shading all x's greater than negative 5. Whereas, what would I have done over here if I had been asked to graph that? Simple. I would have just put a point to the left on negative 5. No shade. And those are the major differences. Really, there's just two. One is that I am shading my solution and I am including an infinite set of numbers when I'm doing basic inequalities. And two is that when I have a dividing or a multiplying, a multiplying. I said I was going to show you multiplying by a negative. Well, and I didn't. Let's do that. I said when you divide or multiply by a negative, you switch the signs. So let me give you, I don't know. I like the 2. The 2's working for me. 2x over, say, a negative 3 is greater than 6. Sure. Okay. So here's a case where you see I have a division problem. I have 2x being divided by a negative 3 instead of being times or something else. We had the negative 3 somewhere else in the problem. I have a division bar. Now, what is the opposite of dividing by a negative 3? Exactly. Well, you knew it was coming, didn't you? Timesing by a negative 3. So whatever I do to one side, times by 3, negative 3, excuse me, I have to times by negative 3. You see me timesing by a negative? Switch the signs. Now, these don't happen as much as the others where we wind up dividing both sides by a negative. These only happen when you see a fraction in the problem like this 2x over 3 or 2/3 x. So then these little negatives cancel out just like I wanted them to, leaving me with this problem. 2x is less than negative 18. It doesn't matter that your answer is negative. It has nothing to do with flipping the sign. The only thing that matters is if you actually divide or multiply by a 3 in your process step to get the x by itself. Last step, dividing by a positive 2, no need to switch. X is less than negative 9. And what would a video be without me showing you how to graph? There's the graph, there's the 0, there's the negative 9, open, and of course shading in the direction I ran out of space. Shading to the left, all x values are less than -9, meaning shade to the left. And that's it. That's inequalities. Now, inequalities can get more multi-stepped. You can have more things going on, but that doesn't mean they're any different than any multi-step equation you ever did. The two main differences, again, you must graph your solution because you have an infinite set of numbers in one direction or the other, and also dividing or multiplying by a negative. You need to flip your sign. That's it. Otherwise, you're dealing with the same exact process as solving equations. Oh my goodness. I hope this video helped you. I know I enjoyed spending my morning with you. And you know what? I'm going to see you. You got it on the flip side.